In this video, we're going to talk about the traveling salesman problem. But before we discuss that, we need to discuss n factorial. So n factorial, or n with an exclamation point, is a basic multiplication problem. Start with that number and descend by 1 every time with multiplication in between. So for instance, 6 factorial, start with 6, times 5, times 4, times 3, times 2, times 1. Always stop at 1. 4 factorial is 4 times 3 times 2 times 1, which is 24. So why are we talking about n factorial? Well, that is going to help us determine the number of unique Hamilton circuits in a complete graph with n vertices, which is n minus 1 factorial, which is n minus 1 times n minus 2 times n minus 3 times 3 times 2 times 1. So how many unique Hamilton circuits are in a complete graph with 9 vertices? Well, that's going to be set up as 9 minus 1 factorial. That's 8 factorial, which is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is 40,320 unique Hamilton circuits. So now that you've been introduced to Hamilton circuits, we can apply this knowledge to solving what is called the traveling salesman problem. So the goal is to determine the Hamilton circuit with the lowest associated cost or distance. This is what is referred to as the optimal solution. We will use the brute force method here. So take a minute, pause the video, and read the example below, and unpause it when you're ready. Okay, so the first thing I'm going to do is I'm going to create a graph for this. So here's my graph for this. Again, M for Memphis, A for Atlanta, O for Orlando, N for New Orleans. Now I'm going to put the cost for each flight in the picture with its corresponding edge now. All right, so how many unique Hamilton circuits are there? Well, there's 4 vertices, so 4 minus 1 factorial. That's 3 factorial. That's 3 times 2 times 1. So there's 6 unique Hamilton circuits in this example. Now, we must examine the cost for each Hamilton circuit, but before we do that, we need to write out all the Hamilton circuits. So let's do that. So keep in mind, this person wants to start in Orlando and finish off in Orlando. Okay, so now we need to be able to figure out the cost. So for the very first one, I'm going to put up here what we're trying to add. So starting with the first one, Orlando to Atlanta, that's 103. From Atlanta to Memphis, that's 229. From Memphis to New Orleans, that's 171. And New Orleans back to Orlando is 139. Add them up, that's $642. For the second one, Orlando to Atlanta is 103. Atlanta to New Orleans is 110. New Orleans to Memphis is 171. And Memphis back to Orlando is 161. Add them up. That's $545. Next one, Orlando to Memphis is 161. Memphis to Atlanta is 229. Atlanta to New Orleans is 110. And New Orleans back to Orlando is 139. Add them up. That's $639. The next one, Orlando to Memphis is 161. Memphis to New Orleans is 171. New Orleans to Atlanta is 110. And Atlanta to Orlando is 103. And this adds up to be 545. So then the next one's going to be what? 139 plus 110 plus 229 plus 161. Adding those up is 639. And the last one is 139 plus 171 plus 229 plus 103 is $642. Okay, so now that those are done, look for the cheapest flight paths. So in this case, he has two different options for the flights, consecutive flights he would have to take. And of course, the cheapest way would be $545 per person. Okay, let's take a look at the next example. So again, take a minute, pause the video to read the example below, and then unpause when you're ready. Okay, so I've drawn a picture for this. The O represents the office, the D represents the duplicating center, the S represents the student center, and L represents the library. So I drew it as a rectangle to make it easier, and I've put all the distances in the graph. We also know, because again, there's 4 vertices, similar to the last example, it's going to be 4 minus 1 factorial, that's 3 factorial, and that's 3 times 2 times 1, that's 6 unique Hamilton circuits. So now we need to be able to write out each of these 6, so I'm going to do that now. Okay, now that we have our 6 unique Hamilton circuits, we need to be able to determine what the distance for each of these are going to be. So I will do the first one only, and I'll see if you can do the rest of them. So the first one would be broken down as OD plus DS plus SL plus LO. So that would be 150 plus 125 plus 250 plus 400, and that's 925 feet. Okay, so take a minute, see if you can fill the rest of these out. Again, pause the video, and then when you are done, unpause the video and check your answer. Okay, so these are the particular values that I got. So if she's looking for the shortest routes, either this first route or this second route would be the shortest. So I might write it out something like this, either office, duplicating center, study center, library, then back to the office, or office, library, study center, duplicating center, and then back to the office. And then, of course, the shortest distance here would be 925 feet.